All right, hi, I'm Rick. I work on input in Chrome and Blink.
And I'm Tim, and I also work on input, and I've been focusing on extensible scrolling recently. So there are a lot of effects funding to scrolling or customizing scrolling that you just can't do well on the web. So I'm going to start off just by showing you some examples of these effects that on native, they're smooth, they're gorgeous, and on the web, you just can't do the same thing. The core scroll header panel from the Polymer project. Can you?
It's here.
This is one of their core elements. It's expected to be used in a large number of apps, and the current implementation is really bad. And that's not the Polymer project's fault, it's just that you cannot do this well on the web. So this is a scroll linked effect. You can see the size of the title changes and the opacity of this yellow block changes. And so if I do it slowly, it looks pretty okay. But if I move quickly, you can see the it jitters a little, and it just feels a little janky. You may not be able to tell that super clearly through the Wolf Vision, but it's not great. And this kind of responding to the scroll offset is really common in a lot of native apps, particularly if some of the. So the next thing I want to show you is a Byers example. So this is from the Google Newsstand, and there's this header where when I scroll down, the header appears. Sorry, and then when I scroll up, the header. And so you need to be responding to the scroll offset. And if you say miss a frame in adjusting the position of this this header, it looks really jittery and pretty awful. So the other important thing to note about these Byers is when I release part way through, it'll snap to either closed or all the way open. So there's no good way of doing this stuff on the web where you pay attention to the scroll offset and then update the UI in response to that. There's a second class of effects that effects. So that's where the user is scrolling, and instead of performing a normal scroll, we want to drive some other kind of effect. One example of this is the overscroll glow. You try to scroll normally. If I try to scroll past the scroll extents, you see that glow starts. And that's not just responding to the scroll offs that this from main UI. It's worth noting here also that Chrome also has top controls, just like the Play Newsstand app did. You can see that the Byers. The top controls act as Byers up and disappear when I scroll down and then snap into place. Another example of scroll customization is snap points, which you may have, in the gallery app, you can see here as I'm scrolling through these beautiful kittens, when I fling, it then snaps to the kitten which is closest to the middle. Implementations of this on the web, and all of them are pretty bad. They don't feel native. So the last example I want to show of scroll customization is pull to refresh. So in the Twitter app, if I scroll all the way, when I scroll past the scroll extent, I get this friction effect where my finger no longer sticks to the content, but slides a little bit, and the header comes down and triggers the arrow moving and the text changing there. So this isn't just simply scrollizing the way that the scroll behaves. So 6 years ago, Tweety introduced this pull to refresh effect on iOS, and they didn't need Apple's blessing to do this. The platform was just flexible enough that they could implement this. Years later, we still can't make good pull to refresh on the web. We need to make the web a place where innovation can happen, not we can kind of hobble along 6 years later. So we've been looking at some ways of making scrolling more extensible to
All right. Okay, so as Tim was saying, it's not good enough for us to just try to catch up with the last 6 years of innovation that's happened on native apps, right? There's a bunch of different effects that people are doing. We could go and build a bunch of CSS properties to give us a bunch of these effects, like snap points is a CSS property that gives you a couple of these. We don't think that's anywhere near good enough. Really, the web as the most open computing platform that has the most, it should have the most creativity. There should be the most innovation in this. The ecosystem should be innovating and trying new things, and we're holding them back from doing that because we're not giving. This is a classic example of the Extensible Web Manifesto. If you haven't read it, everybody on the Blink team should read and understand the Extensible Web Manifesto. It's guiding a lot of decisions at the W3C, and it should be guiding a lot of decisions on the Blink team. And really, what it says is, when we go to add features, we need to come up with framework developers that let them try things out in JavaScript and let them experiment with things that then can feed back into the higher level APIs we've got in the platform. So we're trying to think, scrolling is one of these high level kind of magical things that the browser does, and it's not explained in terms of primitives. On a platform from the ground up, when you're building Android, you start by saying, okay, I've got a kernel. What are the kernel APIs? And now I've got a few kind of primitive. I've got a view, and the view has some basic APIs. And how do I build a scroll view on top of a basic view and that sort of thing? That's how most platforms evolve. Sadly, the web. So we've got to go back now and kind of retroactively extract the primitives out that explain the high-level features. And that's what we're trying to do for scrolling. It's hard, but we think we can make some good progress on this. So there's two, when we looked at all these effects, two fundamental concepts that native platforms have that the web is missing. The first one, to get this extensibility, the first one is we need some form of synchronization. Today, when you write your app code, scrolling happens on another thread on all modern browsers, and you can't write code that stays perfectly in sync. We did that for good performance reasons, but there's this fundamental trade-off between control and performance, and we took in order to get the ability to do things in sync with scrolling or CSS animations or any of our threaded effects. And so for synchronization, we actually see, we've got scrolling happening on one thread and app code running on another thread. There's two ways we could possibly address this problem. Either the most basic thing is you say, no, scrolling has really got a block on the app thread. Let's turn off this threaded scrolling customization, or at least for some scenarios, we want to enable applications to disable this optimization. For them, the optimization is really a crutch that need to be addressed anyway. And so maybe if you really want something that gives a developer a programming model that's similar to what they have on native, they should just be able to opt out of this optimization and say, you know what, scrolling's more, or synchronization is more important to me than being able to do this then gloss over any jank I might have on my main thread. And when you're building this kind of UI in a native platform, we don't force developers to reason about two different threads to compose their UI. So it's reasonable. We don't want to do this by default, but it's reasonable that we should give developers a choice to say, and let me reason about my app on a single thread. So we've got a proposal for this. We've done an intent to implement called scroll delay. It's highly contentious. We've basically, one of the main disadvantages is we've heard from Safari and IE that they're unlikely to ever do this. They think threaded scrolling is, to enable that the web has such a breadth of devices that it runs on, we can't compare directly to native. If we expect people to be able to write websites on their desktop, and there's always going to be web developers that aren't testing on the lowest end devices, if we want to have any usable on lower end devices, that we really should be relying on this threaded system that we've built to insulate the developer more. And so that's a legitimate viewpoint as well. And maybe there's always going to be scenarios where having some threaded effects are essential. In particular, I'm a bunch of different people. It's really hard to reason about the performance of your main thread when you've got the Facebook like button code running on every scroll event and 10 different components all running code on every frame. And so maybe we should also let you synchronize. This is kind of more speculative. This is, but I think it's an exciting idea. We've got Ian Volek has a particular proposal called UI Worker. We talked last week at TPAC with Safari and IE teams about it, and the CSS working group, and everyone said this may be the path where we solve some of these problems in an interoperable way in the short term. We can't expect Safari necessarily to buy into the Silk vision the way we have. So we've been debating these two different paths for well over a year, sides, and lots of rational arguments on both sides. But the conclusion we're coming to is that a healthy web, we need to do both. There's not necessarily one right answer here. We think both strategies are important, especially when we're talking about enabling developers, right? Primitives are supposed to be features. So we should provide, our browser is relying on both of these capabilities today. We should expose those capabilities to frameworks and developers, and we should let them experiment and decide which ones are better for their scenarios and help guide how the platform evolves. I should say, I did mention there's kind of a third choice here, which is these new CSS APIs, new high-level features. I'm not even going to talk about that in any detail here, because this talk is about extensible scrolling and snap points or animation time base that Apple's proposed are nice features for common scenarios ahead of this game. They just help us catch up. All right, so that was the first class of primitives that we need, some form of synchronization. Second is we need some way to also customize how scrolling works. It's not good enough to just say this is linked to a scroll. The examples, it's not just about linking something to the scroll offset. Many examples are, but in the more difficult examples like pull to refresh, we really need to change how scrolling's behaving. So I've got a kind of complicated architectural diagram here. We sat down and we tried to think what's yeah, I don't know why it's not on both screens. You just unpinned. Oh no, now it's on this screen. Now it's smaller. Yeah, so the slides are linked from the, feel free to open up the slides on your laptop. But I'm not going to explain this in detail. This is more to say there's different types of input that can contribute to scrolling. There's lots of examples we've left out of this diagram. But we want to say where do we really need extensibility points? The things that are red right now are places that, the red ones at the top are places where extensibility points exist, the wheel events, and you can zoom the map instead of doing a scroll. Similarly, if somebody's dragging something around with touch, you can handle touch events rather than scroll. But that's not good enough for the scenarios we're talking about here. There's a bunch of things that break down if you just try to inject your extensive, where was I? Right, I said we needed an API that mediates the composition of scrolling. That's this loop here. You see, like, we've got some abstract notion of scrolling is coming into the system, and then we're running this loop of walking up the containing block tree and distributing that scroll across a bunch of elements. And just to help, there's a bunch of different aspects of scrolling that I'll just kind of place on this diagram to show the extensibility point we're talking about adding here, which is this new red box right here, will let you control some things but not others. So for example, when I do a fling with touch, there's some physics there, and this is one of the classic things that doesn't feel right with things like the snap points on the web, right? They build their own physics, it doesn't quite match. In fact, they don't quite have all the information they need to match the physics exactly to the way the browser does it. They can't calculate velocity quite as accurately as we can. So that all happens in the touch input stack. So it really in the gesture detection in the top left corner there. So this is an extensibility point below that. So this will see inputs that include fling. Similarly, if I go almost vertically but at a slight angle, the system actually applies rails, which nudges it to go perfectly vertically. Again, that's in the touch input stack. So that is happening above this level of abstraction. These are all reasons why you really don't want to do this by customizing the touch events, because you got to try to apply all of this stuff. Never mind, you can't. If you customize the touch events, you can't possibly get the composition right. Okay, so the essential thing we need is an API for doing this mediation, and it's actually, for some subtle reasons, it's got to be in an outside-in pattern. It's got to start, it's a recursive API really that starts with the outermost document and walks down the DOM to the target element. And you might want to customize it on the way down, or you might need to customize the behavior as it's kind of bubbling back up. There's tons of other extensibility points we'd like to add at some point for doing additional things, but we think this is the one that'll enable all the scenarios we've shown and a bunch of other scenarios. So this is the one we want to focus on first. But for example, lots of people have argued we should really have an API for getting access to those fling curves. Maybe we should have an API for doing gesture detection, like how do you decide when something is a scroll versus a tap? Those are all good ideas as well, but we think this is the one that's the big bang for the buck. Okay, so that's kind of abstract, high level what we're trying to achieve. Is there any questions or discussion on any of that before we try to dive into some slightly more concrete details about what we think we're doing? Yeah, Chris.
What's the composition you said is impossible?
So for example, the iframe case I talked about, for example, right? If that's how scrolling should work, if dragging diagonally inside of an iframe should scroll the iframe horizontally while scrolling the document vertically, if they're each scrollable in those access, then if the iframe, say, is consuming touch events in some low level, it can't possibly consume just the horizontal touch events and leave the outer iframe to do the vertical ones. That's a bit of a contrived example. The place this really falls down for us in practice is mediating between, like, iframes aren't that common, especially when we're talking about mobile, native mobile, mobile web apps. A big one though is the browser's own scroll effects. So the browser has the top controls that hide and show, right? How do you build a pull to refresh component that adds pull to refresh to your web page using some extensible, like some low-level primitive, without screwing up the browser's top control hiding behavior, right? And in particular, it gets really tricky in that with pull to refresh, you've got the spring effect. You actually, to make that not feel terrible, you need to change the order in which the deltas are applied. In particular, when I pull down, I should be stretching the spring. And then when I reverse direction and go up, normally I would first hide my hidey bars, my top controls, because that normally you'd do the outside thing. We want to prohibit that. We don't want to say if scrolling doesn't need to be delayed, it must not be delayed. And so this makes the implementation a lot more reasonable than you might think from looking at this design. Really, in Chromium's current compositing architecture, we just need to maintain a value per layer. And when you start when you start trying to scroll, the compositor can just look at the value on all the layers in the layer tree and come up with its like unified, like what's the effective scroll delay for the scroll. So we actually think this is relatively straightforward to implement. I'm just starting on that now, but hopefully we're aiming to try to ship this in M41. Okay, so that was scroll delay. Any questions on scroll delay? This is contentious. Maybe people should be yelling at me. Yep.
So the main thread is janky, like as soon as P6 is there still a benefit to scroll delay?
Absolutely. So it's exactly for those. The question was, if the main thread isn't janky, is there a benefit to using scroll delay? Yeah. So if you're building an app, right? You're building the new version of Google Search, right? And you're already designing for a jank-free main thread. Maybe you've got things that you're dragging around with touch events, or you've got effects that you really want to happen as soon as you start interacting. That continues to be the way we think people should be designing their web apps. And it's precisely for those scenarios that you want to opt in to delaying scroll on scroll events, because there's no downside for you, because your page is already responsive. So you might as well get the synchronization benefits. Right. So if you saw, so first of all, other browsers, they're never perfectly synchronized. In Chrome, we've got this best effort sync scroll that if you saw, Sammy gave a lightning talk on that. Because of this best effort thing we try to do where we've got this deadline and we try to give the JavaScript a chance to run its scroll event handler before we produce a frame, you're usually okay, assuming we've calculated the deadline right. But that's statistical, right? That's a guess. And we don't think that's good enough. We want a guaranteed property. And the reality really is that the reality is that you're probably never going to have a perfectly jank-free main thread. I mean, maybe that should be our goal. But what if it's like 99.9% jank-free? What do you want to have happen in that 0.1% of the time? With scroll delay, you'll get a jank. And actually, that's not the worst thing that could happen. When we play with these things, it's way worse to have unsynchronized things moving. For example, in a parallax effect, if the parallax, if you see the content moving and the parallax stuttering, that's psychologically way more damaging to the effect than if both of them janked in sync with each other. Another example is these cases like snap points. The way you might implement that is by the browser scrolled by a bit, and then you might want to counter scroll by a little bit to add the gravity well. If you lose synchronization, you're going to see that as a jitter. A jitter looks way worse than a jank. So this basically lets you say, opt me into jank mode, please. I shouldn't have jank, so it's not going to be a problem. But if I do, I really want jank. I don't want some other crazy UI effect. Chris? Yes. So this lets you implement, definitely you can implement all of the scroll linked effects. So we talk about like the polymer scroll header is one of the simplest examples. Parallax effects are simple examples as well. The Heidi bars, you can implement this. There's still a problem of knowing when the user lifted their finger. So you need touch events for that. So it doesn't let you implement Heidi bars for mouse wheel yet because there's no way to know when the user lifts their finger off a touchpad. But maybe we don't care about Heidi bars with touchpads. Right, yeah, like a touchpad on a laptop sends mouse events. And there's no, it sends mouse wheel when you drag two fingers down the touchpad. It sends no start end event when your fingers change the contact state. So, and we've got a plan for that, but it's not here. We consider that part of scroll customization. So just for synchronization. What else? I mean, there's lots of, I guess if you look at the Google News, what's that? No, pull to refresh customizes the scroll, right? Remember how I was talking about how you've got to change the order in which the scroll deltas are distributed to the different elements? This doesn't let you do that. This lets you synchronize things. Now, we've built demos where we kind of hack around those problems. So that one in particular, maybe we just don't let the top controls hide, and maybe it's not that bad. And so we can actually get 95% good enough in pull to refresh with just this. And we'll share some demos and you can see what that actually feels like. But it breaks down in the composition scenarios. And since what we're trying to do is not solve specific scenarios, but provide primitives to enable people to rationally experiment with things, we don't think that's good enough. No, we should do this first. I think that's a reason to decouple these things. Do this first, and it should unblock people to do things better than they were doing them today. But we're not done until we've done the full scroll customization. Fair? Okay. Anything else? Jacob?
How do I reason about, as a web developer, how do I reason about so you talked about the composition of two components wanting to participate in scrolling behavior together. What about another component that isn't involved in scrolling whatsoever, but it's something like, so I'm doing scroll away, I'm maintaining my frame budget, all my code is nice and tidy, and never chunking more than 50 milliseconds. And then I get to the bottom, and the Discuss commenting system kicks in and says, it's time to load comments. Boom, I'm going to go inject a bunch of inner HTML, run a bunch of stuff, and now my frame budget on the main code is out of my control. How do we isolate the ability for my customized scroll code to not be impacted by what's very commonplace on web, which is the matching up of other things that I didn't write.
Right. Let me try to reproduce that or repeat that for the mic. I would summarize that as if your page is a composition of different things, How does the developer reason about how they set this relative to things that may be adding jank to the page, right? And so I think that's just an example of the question, like, how do you reason about performance in a system that's a mashup of a bunch of things, right? You want to be able to reason locally. You want to be able to say, author of component A reasons about performance for component A, author of component B reasons, right? As far as I know, that never works anywhere for performance. Right? Performance seems to be something that you have to reason globally about, and that the only way to really reason about performance is to understand the app and everything that it includes, and have good tools that can show you everything. That and I agree that means that it may be hard to decide. You may build a component that works beautifully in isolation with scroll delay, and then somebody may use that component in some other page that has jank. And then that component doesn't work. Then that causes that component to be janky, right? By putting this in CSS, at least we contain the damage to that component. And the author of that component has to say, this component is designed only to be used in jank-free pages, right? If you've got discuss loading like big things that, hopefully a lot of those are browser bugs. Hopefully we can fix that with our scheduling work, and we can do a lot to improve that problem. But we're never going to get away from this problem of there's absolutely scenarios where it will not be appropriate to disable threaded scrolling.
Embedded in that was sort of a prioritization of handling input, right? Like those were your most tight, narrowest goals, right? Everything else is like, okay, when you have time, yield, do your backlog tasks and whatnot. How can we make that possible for custom handling, right? Like, because in the discus example, right, like it's probably okay to defer its loading, but I don't really have the ability to schedule that.
We need to discuss to do surface area on the web to get optionality. Yeah. That currently the entire web is modeled as everything attached to the DOM is mandatory, you must do. The user expectation, in fact, is the other. We're used to the old days where images come in afterward, right? That users are completely willing to make this straight, right? Infinite scrollers, even in native apps. This is not possible on the web. It should be possible once it is possible to articulate developer intent and user expectation. Then the execution model becomes scheduled. As long as we don't tweak that, this is unsolvable. Right?
All right, we're almost out of time. We're currently taking twice as long as we did in our dry run. So, yep, Dimitri. Yeah, I agree. I would love to have this debate. I've been wanting to get Jacob and Nat in the same room to bash it out for a while. Let's have a breakout. Hug it out. Sorry. But it's partly due to feedback like that and talking with the different viewpoints on the IE and Safari teams that we're also excited about the other option here, which is empowering the thread to be able to decompose your application into things that run off thread and aren't subject to jank in the same way. But I'm not going to go into design here at all. Ian's giving a talk later today. Definitely go to that talk. It's going to be exciting. Oh, sorry, it's moved. 2:15 here. Yep, that's what I get for putting times on the slides. Okay, so the next is the scroll customization stuff that we've been talking about that we've called before scroll. And Tim's going to tell you about that.
Yeah, so this is a relatively rough idea about how we could implement scroll customization. One thing we want to get out of this is a common, or at least as common as possible, an API between the main thread and possibly a whatever UI worker solution we get. Right now, we haven't really thought too much about that. This is just an example of how this could look on the main thread. And we're kind of in the middle of switching over from thinking about this in terms of a DOM event called before scroll to some callbacks. So if you're looking through some of our documentation, it might be a little confusing. But this is an example of how you might implement scrolling a div the way the browser does in JavaScript using this API. So we believe that if we're going to have an API for scroll customization, it needs to be powerful enough to emulate the scrolling the browser does. So this scroll method would be called on, say, an over scrolling div, and it gets past this scroll state object. The scroll state object is going to include the deltas, so how much the scroll is scrolling by, things like the current velocity, whether or not this scroll is inertial, so if you're flinging, whether or not the scroll is ending, all kinds of information which will let you implement these complicated scroll customization effects. So the first thing that a native scroller would do is it looks at the y delta and says, if there is a y delta and we can scroll vertically, figure out how far vertically we can scroll. So if we're going to hit the scroll extent after our delta is only half consumed, we figure that out. So how far are we scrolling? And here in this example, we're assigning that to dy is how far we're scrolling. And then we modify this dot scroll top. So we actually scroll that far. And then we just repeat this logic for the x-axis. And the final thing that we do is we mutate our scroll state object to say, you've now scrolled this far. And so then when you have this, these scroll composition scenarios, future scrollers will see that they're only supposed to scroll the amount of delta that's left over from this process. So this is for a single element, which is scrolling. Rick earlier mentioned this recursive traversal down the containing blockchain, and that's also going to be overridable. So this is what that would look like for native scrolling. So we have this distribute scroll method, and first off, the documents distribute scroll method will be called. And this is going to take the exact same scroll state object. And so the thing that's a little tricky here is this pop scroll chain method. The scroll state initially is going to have the chain down the containing block tree from the document to the element which is being scrolled. And so the first thing we do in the documents distribute scroll method is we pop the first element off the scroll chain. So that's going to be my child in the containing block tree. And we just call distribute scroll on it. So the document's child is going to do all of its scrolling stuff and potentially mutate the scroll state, indicating that some of the scroll was consumed. And then the element is going to scroll itself based on whatever remaining scroll delta there is. And so this is going to recursively traverse down the containing block tree, scrolling all the elements appropriately. And so if you can override this scroll and this distribute scroll method, you can customize scroll distribution however you want. This allows you to implement things like pull to refresh and snap points really easily, and only overriding the bits of native scrolling that you actually want to override. So you can use the browser's native velocity calculation, or you can use the browser's native scroll distribution if you don't care about scroll customization and only care about responding to scroll. So I'm going to show you one more, slightly more complicated example. This is how document scrolling would work, which is a little bit hairier because we have to worry about top controls and the overscroll glow. So the first thing that we do when the document is scrolled is we check if the top controls need scrolling. So we call top controls.scroll with our scroll delta, and it may, here it's going to return however much the top control scrolled, and then we mutate our scroll state object to update it to say, okay, now you only need to scroll whatever scroll is remaining. Here we're also handling that top controls snapping. So if the user's listed their finger, we tell the top controls to animate into place. We then go ahead and actually scroll the document. And supposing there is still some scroll delta left over, we move on and pass that remaining scroll delta to the overscroll effect. And draw the blue glow or whatever it is. And what's really neat about this is if you as a component author on the web want to implement top controls, you do it in exactly this way. It would look exactly the same. So I'm going to show you two quick demos. Right now, we've got a kind of a hacked up patch where we're doing this using a before scroll DOM event, and we don't really have the composition stuff completely worked out, but there's still some cool stuff that you can do now that you could not do previously. So the first demo that I'm going to show you is snap points. So what's cool about this is we use the browser's native velocity calculation, and we only override the bits we need to. So you can see I fling the kittens, and it snaps to centering on one of these images. And so because it is able to use the browser's native scrolling as much as possible and the browser's native velocity calculation, it just feels significantly more native than most of the other snap points implementations. So this is a pull to refresh demo. And so you see I can fling into the effect nicely, and it uses the browser's native velocity computation, and then it transitions into a little physics simulation that's driven by a RAF callback. So are there any questions? Yeah.
Well, first of all, so Dimitri said you like callbacks, not events, right? We should debate this offline. Anna, who's like the DOM event spec editor, told us this is an abuse of DOM events, that the browser shouldn't have DOM event handlers. I mean, and we could maybe just debate that. But what was more important for us is we're not sure how to integrate the notion of events into UI worker. And maybe we should try harder, but DOM events feel like they're probably too heavyweight for this. And also, we wanted to follow a pattern. Like, we're trying to explain the browser's primitives. We wanted to follow a pattern that was consistent with what the Glitter folks were doing as well. Like the pattern that if you look at how this works in native UI frameworks, it's a very similar pattern to custom paint in native UI frameworks, right? There's some recursive painting algorithm that starts at the top and walks down and paints all the children. It paints its children. And then you can customize it on the way down or on the way up. And so shouldn't we have a similar, it kind of shocked me when I realized that this pattern was everywhere in native UI frameworks and nowhere on the web. So I think like customizing painting, customizing layout, customizing hit testing, customizing scrolling, I think those use a similar pattern in native. They should probably use a similar pattern on the web too. Ian.
The scroll chain thing is really neat. Is customizing the scroll chain so you can bubble to some arbitrary thing?
Yeah, could you customize the scroll chain to bubble somewhere else? Yeah, absolutely. I don't see why not. I mean, the browser goes up the containing blockchain, but actually not all browsers are consistent with that. I think Firefox goes up the DOM ancestor chain, not the containing blockchain. So maybe there's reason to do it differently. There's also scenarios. Gmail has a scenario where if you try to scroll on the ad on the side of Gmail, it scrolls the content instead. And today that's super janky because they are actually listening for wheel events, and it doesn't work with touch. If they're listening for wheel events on that thing and then they're changing the scroll, you just want some different distribution that's not following necessarily your DOM hierarchy. Cool. All right. Well, if you have any more questions, we'd love to talk about it. We've got a public mailing list where we debate all these kind of things, inputdev@chromium.org, or find us. Thank you very much.